What's up, guys? I am in this video. We're doing the SAT practice test number 10. So, with this video, we're covering only the first 9 questions of the non-calculated portion. I recommend before you even watch this video, attempt the questions on your own. So, in the description, there is a link to the practice test itself for you to try them on your own. It's okay if you don't know, it's okay if you get stuck, but try the questions beforehand and don't look solely on the answers. So let's get started. All right, so the non-calculator section, as you can see, 25 minutes, 20 questions, and again, no calculator. So any calculations I do for a question, I will do them on the screen. So let's look at number 1. What value of z satisfies this equation, 2z plus 1 equals to z? So we're just trying to solve for z here. So to solve for z, you get z by itself and move everything to the other side. It doesn't really matter if you want your z variable to the left or the right. I may just go ahead and move the 1 to this side. And with this math, you may be able to do it in your head. That's totally fine. And then I'm going to move the z to this side. So usually with the non-calculator section, you see like a lot of simple arithmetic. So answer number 1 would be just B. And if you want to, you could plug in -1 into your equation to verify it's correct, but we don't need to do that. Look at number 2. A television with a price of $300 is to be purchased with initial payment of $60 and weekly payments of $30. So let me highlight that real quick. Price is $300, initial payment is $60, and weekly payment is $30. So which equation can be used to find a number of weekly payments, W, to complete the purchase, assuming there are no taxes or fees? So this is a fun one because when I saw the word initial and weekly, my mind automatically went to a linear relationship. So you may be familiar with the y equals mx plus b. Don't forget, m is your slope and b is your y-intercept. And instead of saying slope, you may hear rate of change or something that's affecting it on a consistent basis. And instead of y-intercept, you may hear initial or the starting place. So in this case, instead of saying x, I'm going to say w because for a certain number of weeks, I get a certain price. Now, my television costs $300. It says my initial payment is $60. That initial, again, is represented by your y-intercept. So in my equation, instead of saying b, I'm going to say 60. I have weekly payments of $30. So for and every week, I want to pay $30. Now this is kind of nice because it just says what equation can be used. And here we only have one answer choice that fits us. We don't need to solve for W, we just need to get the equation. Biggest thing on this question is again, you see the word initial, see the word weekly. That should kind of lead you to a think of it as a linear relationship. I mean, even your answer choices are in that format. Let's look at number 3 now. So we got a table of shipping charges. Merchandise weight is in pounds. Shipping charge is on the right. So the table above shows shipping charges for an online retailer that sells sporting goods. There's a linear relationship between the shipping charge and the weight of the merchandise. Which function can be used to determine the total shipping charge f of x in dollars for order with merchandise weight of X pounds? So biggest thing here that I saw off the bat was reading it is hey, linear relationship. So again, going back to that, I'll write down here, y equals mx plus b form. But if you look at this though, and so this would be your x, this would be your y. That's they tell us shipping charge is f of x, merchandise weight is x. But if you notice here, there's not a consistent relationship happening between these two. It's just not consistent. Here's a plus 5. So between 5 and 10, that's like plus 5. Between this 10 and 20, that's plus 10. And 20 and 4 is plus 20. And then vice versa on the other side. So this question off the bat, I know is going to take me some time. So if you're actually doing the SAT test and you see you're trying to find an equation, you try to find a linear equation, and it's going to involve kind of some arithmetic, some math, basically it's going to take some time, I would go ahead and skip this and come back to this question at the end. Now, I'm actually going to work it out right now, but if I was taking the actual test and I saw all these calculations I'm about to do, I probably would skip it and come back to the end. Now, let's actually see how we figure it out. So, we need to figure out what is my m and what's my b. So again, the m is your slope, and slope is the same thing as what? Change in y over change in x. You may remember a formula of y2 minus y1, x2 minus x1. We can take any of these four ordered pairs or 4 points, and we can use that to find our slope. Again, it doesn't matter what ordered pair we pick, but just remember, you're doing all these calculations by hand. On the bottom, it's x2 minus x1. So I'm going to do some dividing here. Try to be smart of what you pick. I'm about to show you some different scenarios. If I was to pick these 2 points, and let's say the 10 was the x2 and the 5 was the x1. On the bottom of my equation, that would be a 10 minus 5, which is 5. So I had to do some dividing by 5 in the end to find the slope. If I was to pick now, let's say these two, so it'll be a 20 minus a 10. That'll be a 10 on the bottom of for my slope. And let's say maybe these two, a 40 minus a 20. Now, there are different scenarios we can do as well. For example, like a 40 and a 5, maybe a 40 and a 10, a 20 and a 5. But just think about this. When you do your dividing, would you rather divide by a 5, a 10, or a 20? This is all on your math skills. I would recommend, though, pick the 10 because that's going to be a lot easier to do dividing. So on this question, I'm going to pick the order pairs. 20, 31.79. So 20, 31.79. And 10, 21.89. Again, you could have picked whatever 4 order pairs here, but be smart about it. Make your life easier. You're doing math without a calculator, so make your life easier. Sweet. Doesn't really matter what's your x1 and x2. I'll just say this is x1 and this is x2, and I'll say this is y1, this is x2, this is y2. Again, doesn't really matter. Just make up your mind. So when I do this, I'll have to do it here on the bottom. So it's going to be kind of tight. With this here, change in y over change in x. And now I think about it, I'm going to switch these up. And you'll see why. I'm going to say this right here. This is going to be my x1 and y1. And this right here is going to be my x2 and y2. Not y2. Only reason why, because when I actually, so y2 minus y1 over x2 minus x1, when I actually plug these in, I'm going to have a 31.79 minus a 21.89. I just wanted to avoid any sign of negatives. Yes, it's still going to be the same answer. It's still going to be the same answer, but since you're doing math by hand, it's nice to try to avoid any negatives. So plug in your x1 and y1 and your x2 and y2, and then man, just got that. Fortunately, you just kind of work it out. So I know on the bottom it's now going to be 10. 31.79 minus 21.89. If you haven't done subtraction by hand in a while, I know. So try your best. 9.90 over 10. Now when dividing by 10, thankfully, it's a lot easier than dividing by everything else. If it was a 20, a 5, 15, we'll have to do long division. But remember, whenever you're dividing by a multiple of 10, I can just move the decimal that many places to the left. So since this 10 has 1 0, I'll move it one place to the left. That means that 9.9 divided by 10 is the same thing as 0.99. I did all that just to say that my slope is now 0.99x. Now, here's the thing that marked off C and D, and now we should find our B. So again, I'm doing all this work, and this is building on question number 3. So I would have skipped this question and came back to the very end if I had more time. Now, different ways to approach to find your B value. I'll show you three different ways. So the first way is, okay, you have 4 different order pairs. Plug in one of the 4 order pairs. So I'm going to use the pair 10 and then comma 21.89. Again, I picked it because 10 is a nice number. You can take this order pair and plug it into the equation y minus y1 equals m x minus x1. You can plug in the 10 for your x1 and the 21.89 for your y1, and then plug in your slope as well. That will get you your answer, and that'll be good. Second option is plug in your points. So we got here 10 comma 21.89 into the current equation that you just found. So this y equals 0.99x plus b. Instead of saying y, I can say 21.89. And instead of saying x, I can say just 10. Again, and I'll show you what this means. So y minus 21.89 equals, my b was 0.99, and my x is that, and x minus 10. It doesn't really matter which way you do. Here I'll do an orange. This one or this one, it doesn't matter. I'm going to pick, and I'll do this, so option 1, option 2, and option 3 is going to be about logic, and I'll show you that at the very end. I want to pick option 2 just because it's a little bit easier, a little bit nicer. So here I'm just trying to solve for b. So 21.89 equals, well, 0.99 times 10 is you just move the decimal one place to the right. It's one place because there's 1 0 on this 10, and it's to the right because we're multiplying. So 0.99 times 10 is just 9.9, and that's just plus b. And then just to solve for b, we subtract 9.9 from both sides. Again, it's probably been a little bit since you've done this. It's 9.9, and I'll say 90. So when you do this again, it's okay to make mistakes right now. Just get more practice. Oh, my bad, and then 11. So that means 11.99 is equal to my b value. So we know what our m is, we know where our b is, therefore y equals 0.99x plus 11.99, which is equal to b. If you would have continued on with route number 1, you still would have got the same answer. Third option was, I said, by logic. So again, if you notice here, the increase from the first 2 was plus 5. Increase from from 2 and 3 was 10. And increase from 3 and 4 was 20. And if you look at this part right here, increase from the first 2 was maybe around 5. From the second 2, around 10. And from the third 2, around 20. Now you could have kind of eyeballed it, as in like my slope might be, because again, your slope is your change in y over change in x. So you could have done, okay, this 5 over this 5, which is 1, this 10 over this 10, which is 1. Therefore, my slope would be around 1. So that would give you A or B. And to figure out what the y-intercept would be here, technically A is saying it's plus 0, and B is saying it's plus 11.99. This means that it's going to start at 0, and this one is going to start at 11.99. So if we follow this same train of logic, notice as the merchandise weight increases, the shipping charge increases. So this first one increased by 5, and the second one by 10, third one by 20. So to figure out this over here when our merchandise weight was 0, that would give me my starting y-intercept. Now, it's not going to have a different, it's not going to have a big change right here. So whatever this number is changing, the change is not going to be above 5 because we need to be consistent. It might be like a plus, maybe a plus 4 or a plus 3 or plus 2, plus something like that. Again, this is using my logic. You don't really need to do that here. You can just kind of work it out the math, but please, I recommend skipping this one to the very end of the non-calculator section and coming back to it because it's involving a lot of math. But B is your answer choice here. All right, let's look at number 4. The line in the xy plane above represents the relationship between the height, h of x, in feet, and the base diameter x in feet for cylindrical Doric columns in ancient Greek architecture. How much greater is the height of a Doric column that has a base diameter of 5 feet than the height of a Doric column that has a base diameter of 2 feet? There's a lot of words here. Let's focus on our question. Our question is again, says how much greater is the height of a Doric column, and that height has a base diameter of 5, than the height of a Doric column that has a base diameter of 2. So it looks like here the height is h of x. Remember, that is the same thing as y. H of x, f of x, g of x, whatever that is, that's the same thing as y. That means the y-axis is my height, and the base diameter is my x. So I'll say base diameter. So just for reading my chart alone, it's saying here that when I have a base diameter of like 3, I have a height of 21. Base diameter of 2, height of 14. Base of 1, height of 7, and so on and so forth. So looking at this question now, it says how much greater is the height of a Doric column that has a base diameter of 5? Well, when I have a base of 5 feet, my height is what? Well, let's look at our graph. When I have a base of 5 feet, I have a height of 35. I want to know how much greater is that height than the height of a column with the base diameter of 2 feet. So I'll do that. When my base is 2 feet, my height would be, well, let's look at our graph again. So when we have 2 feet for base, 14 for our height. So question basically, how much greater is the 35 and the 14? So 35 minus 14, again, just arithmetic. So 5 minus 4 is just 1. 3 minus 1 is just 2. So that means my answer would be 21 feet. Looking at number 5 now, if x is greater than 0, which of the following is equivalent to the given expression? The square root of 9x squared. Now with this kind of goes back to some skills you learned in, I would say probably algebra 1, for sure in algebra 2, and geometry. But I think the earliest you learned them is in algebra 1. You can break apart square roots. This is allowed to do because of the law of exponents. Instead of saying the square root of 9x squared, I can break this up as the square root of 9 times the square root of x squared. Again, this is by the law of exponents. I was allowed you to do that. And the biggest thing here is it's multiplying. That's why I could break it up. So we know the square root of 9, that's just 3. So that marks off C and D automatically. And the square root of x squared. So if you didn't know, the square root of x squared is actually just x. Some teachers may tell you to kind of think of it as like the opposite operation. The opposite of a square is a square root, so on and so forth. Whatever helps you kind of remember it, but the square root of x squared would be just x. Looking at number 6 now. What are all the values of x that satisfy the equation above? The equation is x squared minus 1 over x minus 1, and that equals negative 2. So we need to basically solve for x here. Now, there's different ways to do this. I probably recommend the easiest is just cross multiply right here. Now, I set the right side over 1 because you can really divide anything by 1 and not change its value. So when I cross multiply both sides here by itself, the left side is going to be x squared minus 1, and then the right side is going to be negative 2 times x minus 1. Now notice when you solve this here, you can use this thing called the distributive property. So I'll distribute the negative 2 to everything on the inside. Negative 2 times x is just negative 2x. Negative 2 times negative 1 would be just a positive 2. So it says, where are the values of x? I'm solving for x. I have an equation where I'm solving for x. So let's get all the x's on one side. And since I have an x squared, that part means I have a quadratic. So we need to make the right side equal to 0. So let's just go ahead and move everything that's on the right to the other side. So I'm going to add 2x here, and I'm about to do a lot of steps. So you can either do this all in one step or break it apart like I'm doing right now. My biggest thing here is as long as you know the math. On this left side, x squared minus 1 plus 2x. I can't combine any of those, so just bring it all down. The right side now, the negative 2x plus a positive 2x is just 0. I'm left with just a 2. And now move over this 2 to the other side. I'm left with now, I'll write it right here, x squared plus 2x, and then negative 1 minus 2 is going to be negative 3, and that equals 0. So this should bring a reminder of how to solve for x with a quadratic. We need to factor this. So I need to think of two numbers that multiply to be my c variable, which is negative 3, and add up to be my b variable. So two numbers that multiply to be 3, well, it's going to be 1 and 3. And that's the only two numbers that work. So between those two numbers, I want to somehow add these two and get positive 2 in the end. Well, if I had a positive 3 and a negative 1, that adds up to be positive 2. So a positive 3 plus a negative 1 is positive 2, and also a positive 3, and actually I'll write that here. Cool. So a positive 3 plus a negative 1 is a positive 2, and a positive 3 times a negative 1 is negative 3. This is good because, hey, it matches up with my b and C variables respectively. So life is good. Now, almost final step. To solve for x, we can set the first binomial equal to 0, and then the second binomial equal to 0. I'm allowed to do this by this thing called the zero product property. So to just solve for x on this first one, nothing too crazy. Subtract 3 from both sides, and I get x equals -3, and then just add 1 to both sides. So x would just equal +1. Here's the thing though, if we look at our answer choices, it's not B, and D says -3 and -1, so it can't be that. But now we're left with just -3 and a +1 as our possible answer choices. But we got that for both our answers. So to figure out which one is correct, let's read our question again. What are the values of x that satisfy the equation above? Basically, I want to be able to plug in one of these two x values and get -2 in the end. And when I solve for x, I got two possible answers, -3 and +1. However, in this case, only one of them works. And I'll work it out here, and I'll work it out here. So if I was to plug in -3 to this equation, I want to somehow get a -2 in the end. And I'll do like a little question mark, because I don't know if it works yet. I'm running out of space, so I'll kind of work it out over here. So let's work this out, this left side, to see what is it equal to. -3 squared, that is a -3 times a -3, that's a +9. -3 minus 1 would be just a -4. Now here, a 9 minus 1 is just 8. And 8 divided by -4 is -2. And thankfully, hey, here, -2 is the same. That means -3 works. Let's check to see if, and I'll put a divider here. Let's check to see if x minus 1 works. So when x is 1, is my corresponding answer -2? Let's work it out. So looking on this one right here, the very top, 1 squared minus 1, well, 1 squared, okay, I'm going to have to work it out here. Cool. 1 squared is just 1, but 1 minus 1 is just 0. At the top, we have 1 minus 1, and I'll do this here. 1 minus 1, which is 0 over 0. And unfortunately here, we're dividing by 0, and that is not possible. So actually, in this case, only -3 works. This would lead you to the answer choice, obviously, but biggest thing here is don't stop after you get to this step. Don't just guess between A and C just because that's the only two answer choices you have. Don't stop there. Finish up, we got 3 more to power through. The graph of y equals f of x is shown in the xy plane above. This is a pretty straightforward one. What's the value of f of 0? So remember, f of x is the same thing as y. So when I say f of 0, that's saying when x is equal to 0, what's my corresponding y? So on your graph, find a place where your x value is 0. That's clearly right here. And see where your corresponding y is. So that would just be a +4. Let's do crazy on that one. Number 8, some geometry here with angles. In the figure above, point B lies on the line AD. What is the value of 3x? So if you notice here that this equation, I'll just do it in this color. This right here is a right angle. And notice here AD is a straight line. So don't forget, a straight line has 180 degrees. And the little square in the corner, that means 90 degrees. So basically, this angle, or let's do it in 10. This angle plus this angle needs to equal 180. And since the left side equals 90, that means the right side equals 90. So the reason why that's helpful, because I can end up saying that this angle plus this angle plus this angle, all of these three added to be added to be 90. So the angle of x plus 2x plus another 2x, that has to equal 90 degrees. Now when we do this, we can just solve for x and then from there plug that into the value of 3x. So this left side now becomes x plus 2x plus 2x, that is equal to 5x. And then just to solve for x here, I'm going to divide both sides by 5. Now when I do that, again, 9 divided by 5, you may just need to work it out on one side. It's totally fine if you don't know that. But 5 goes into 9 one time. That's 5. 4, bring down to 0. 5 goes into 40 8 times. That means 90 divided by 5 is 18. Don't go ahead and answer and just say the answer is A. I need to find the value of 3x. We found the value of only x. So to figure out what is the value of 3x, plug in 18 for your x. So 18 times 3, I know that's 54. If you don't know how I did that, 18 times 3, again, just multiplying this stuff out. 8 times 3 is 24. And then 3 times 1 is 3. Add a 2, that'll be a 54. Biggest thing here is, hey, don't just go ahead and jump and say the answer is 18, because that's not correct. That's the answer for x. We need to figure out the answer for 3x. And then final question here, another linear equation. That's like the third or fourth one we've had so far. So they give us a graph with a line here, line L. So which of the following is an equation of line L and the x, y plane above? So again, in case you forgot somehow, the equation for a linear relationship is going to be y equals mx plus b. Don't forget that your m is your slope and your b is your y-intercept. Again, it helps just, and look, and notice here on their answer choices. I have the equation y equals mx plus b, where y and x are on different sides, but they have it such that x and y are on the same sides. This is actually in standard form. So once I get my equation and y equals mx plus b, I'll need to move it and make it match standard form. So here again, finding my m variable, actually I'll find my b first. The b is pretty quick to find. Remember, your b variable is always going to be the y-intercept. So here it's just a place across the y-axis. Notice it crosses at -4. That means my b would be -4. There are different ways to find your m. We can, if we want to, plug in some value, some ordered pair, any ordered pair that this graph touches, like maybe this ordered pair or this one or even this one, and so on and so forth, to figure out what is my m. I could do that, but don't forget, you probably learned this in Algebra 1 of like, hey, it's the rise over the run. So between any 2 points, that can be used to help find my slope. So let's start the y-intercept. So let's start at this point, 0, -4. So when I start at this point, I notice I rise 1, and then I run 1. So I rise 1, and I run 1. Again, it was rise over run. So I would rise 1, so 1 in the positive direction, and run 1 in the negative direction. But a positive over a negative is just negative. So that means my equation would actually be a -1x minus a 4. And since this right here is a 1, I'm just going to say a -x. because, well, you don't really need to do that. That's cool. Remember, I want my equation in standard form. So move the x variable from the right to the left side. So I'm going to add x to both sides. I'm going to get on this left side now an x plus a y. And on the right side, I get now only a -4. So that looks like corresponds to answer choice C. X plus y equals -4. That's it for this first video. It's a long one. But if you haven't tried the next couple of questions, please try them on your own before you watch my next video. Thanks for watching.